Evening, one and all. On behalf of our college, I, K. Deepika, extend a very sincere warm welcome to all of you present in this session of guest lecture on Design of Machine Members 2. It's my pleasure to introduce today's guest speaker, Dr. S. Solomon Raj sir, Associate Professor in CBIT, Hyderabad. It is an honor and privilege for us, sir, to have you with us today. I am sure we will be enriched by the guest lecture, and once again, I welcome you, sir, and all. Now, I request Dr. Solman, sir, to address the session. Thank you, sir. Thank you once.
Thank you, Deepika madam, for the kind words. Am I audible clearly?
Yes, sir. It's
Yes,
audible.
sir.
Okay, thank you so much. And I first of all thank the Guru Nanak Institute of Technology for having invited me for this guest lecture, and the coordinator and my good friend and Sri Hari sir, when he has contacted me, I agreed. And it's my privilege sharing whatever the small thoughts I know with regard to the design of machine members. So having said these few words, can I share, sir, now?
Yes, sir. You can share, sir. Yes, sir.
Yeah.
Yes, sir. Just 1 minute, sir. I will stop my sharing. Then you can share.
Okay, sir. Okay.
Yes, sir. Now you have all rights.
Right, sir. Now I am entire screen. Select window screen or this one. Entire screen. Yeah, is it visible, sir, now?
Yes, sir. Yes, sir. Okay, sir.
Yeah, is it visible here, sir, now? Fine.
Yes, sir. It's clear, visible,
Yes,
sir.
sir.
Your screen,
Okay.
everything.
So thank you so much, dear sirs, and hearty welcome to all the participants and dear students. And I take this privilege to share a few of the thoughts what I have with regard to the design subject as such with regard to the mechanical engineering, and specifically to the design aspects what we need to focus with regard to the sliding contact bearings. So having said these few words, what I want to tell is, see, in design of machine elements or in design engineering, most of the components you might have designed even in the first part of the design engineering what we studied, that is design of machine members 1, and now we are in the design of machine members 2. So the first and the foremost thing what we all need to keep in mind while designing the machine members is, first of all, every one of us should know what is the purpose with which I am designing a particular component. So in the design engineering, when we see, especially in the manufacturing industry, we do manufacture so many components which are helpful in producing so much of important goods that will help survive the human society. So in this process, whenever I'm taking up a manufacturing process, we do design so many components that will aid in the process. So accordingly, in the first part of the engineering, as soon as you enter into the course, I'm very sure we all people get introduced to one fundamental subject such as engineering mechanics. First of all, we do study, and apart from that, the second portion of this subject, you people get introduced to mechanics of solids or mechanics of materials, where our prime focus is on understanding how the behavior of deformable bodies can be modeled. So in mechanics of materials, most of you people have studied this course as a part of engineering. So our focus is on understanding how a particular material will respond when it is loaded by an external loading. So the prime objective there is, whatever the material it may be, when we subject it to different types of loads, the material is going to behave according to its own constitution. So whether the material is isotropic or anisotropic or transversely isotropic, variety of materials models we have got in engineering. And as a part of this BTech course, most of we people do study only the theory related to isotropic materials. So we do understood to some extent how a isotropic material is going to respond whenever we subject it to external loads. So in that aspect, we do study what do we mean by axial loads, what do we mean by bending loads, what do we mean by torsion loads, twisting loads, and the stress strain curve, and how to interpret the stress strain curve, and what is the difference between, the very important point, what is the difference between the strength and the stress. Okay, these two are primary important to engineer who is basically into the field of design engineering with regard to the materials. We know that stress is basically a state. It is a state, whereas strength is the capacity. This is the fundamental difference our design engineer need to understand. So stress is basically a state. It can vary from 0 to the capacity, but the capacity is the maximum amount of strength a particular material can possess. So if at all, if I am choosing a particular material for a given application, as a design engineer, I should know what are its strengths. Can this material, what I am choosing for this application, will it withstand and serve the purpose which is intended for? Because every component, dear participants, what we design, every component has got its intended purpose. So that is the prima facie requirement we should all keep in mind. So what is the purpose for which I am designing a particular component? So having said this, you people might have designed what you call in the very first unit of this one. Let us say what very most widely used one of the mechanical component is the shaft. Let us say simple component I want to take. Shaft we want to design. First of all, once I want to design a shaft, I should know what is the function of the shaft. Shaft is basically used for power transmission. You know that. So once you want to transmit a particular power, let us say 50 kilowatts or 5 kilowatts is the power I want to transmit. Then comes the role of you great design engineers who are going to be the future people who are going to be at the helm of affairs, and you are going to run the manufacturing industry, and you are going to come up with new designs if you people possess a wonderful knowledge with regard to the basics. So once this is the power need to be transmitted, and somebody from an industry comes to you and tells you, please design a shaft so that I want to transmit this particular power from a so and so source to a so and so sink. So he will give the distance. This is the source for me and this is the sink. In between this, he says, I want to transmit the power. Then keeping this physics and application in mind, as a design engineer, first of all, I will decide whether I want to go with the gate drive, belt drive, or the sprocket drive, or I want to go with the shaft. So these are the major decisions as a design engineer tomorrow in a real-time industry we are going to face. So the purpose of the shaft is to transmit the power from one location to the other location. In the process of power transmission, I don't want the shaft to fail, and I want a particular shaft to have some life. Let us say I wish this shaft to function very well for 10 years or 15 years or 2 years, so on and so forth. So every component what we design, dear friends, it's going to have a purpose. Understanding the purpose is the basic requirement a design engineer has to go on. Most of the people, without understanding the basic purpose, we will try to mostly go ahead with the design process and try to make stress calculations, strain calculations. But all these things do not prove more fruitful until unless I understand what is the purpose. So like this, you have studied about the couplings, and you people have studied about C clamps, okay, and the different theories of failure. All these things are the few of the technologies which you might have already got exposed to as a part of design engineering. So prima facie in any design engineering, we want to design the components and it should serve the purpose. So in that aspect also, in mechanical engineering, we have one important component which is finding major application in almost all the rotating machinery. If you observe, in all the manufacturing industry, most of the machinery are rotating in nature. Most of the machines do rotate because most of them are driven by electric motors. So it is going to have a rotary motion. So whenever the things are rotary in motion, and whenever a shaft is there to transmit a power, you know that first of all, as a design engineer, before talking of this one, we need to design a shaft. And to design a shaft, shaft can be designed from 2 points of view. One is a strength point of view, and the shaft can be designed from stiffness point of view. So either of these 2 points of view will tell me what should be the material I should use for the shaft, and what should be its diameter, and what should be its length, and what material it should be made up of. So by making these strength and stiffness calculations, making use of the solid mechanics, I do come up with all these parameters that are required for the shaft. So now upon the shaft, dear students, if you observe in the course of power transmission, we are going to mount the gears. Okay, shaft may contain a gear, because obviously without this one you cannot transmit the power. A shaft may contain a pulley, and accordingly we have different types of pulleys here, and a shaft may even contain a sprocket if at all if we are using the chain drive. So whether I can mount a gear, or whether I can mount a pulley, whether I can mount a sprocket on a shaft, loads are going to come onto the shaft. And the shaft is basically a rotating member. Shaft is basically a rotating member. And this rotating member, I need to support it at some point in time. Now the big challenge for engineers with regard to the requirement, there is a shaft for me. Yes, I have a shaft here, and this shaft is rotating because it is transmitting power. It is rotating, and I need to support it. That is the bigger challenge. I need to support it. So we do support these rotating shafts upon an element what we call it as a bearing. We do support it on an element what we call it as a bearing. Okay, so bearing is at most important and most widely used component in mechanical engineering, which finds a wide variety of applications. Now when it comes to the designing of a bearing, say for example tomorrow you as a design engineer, somebody will ask you, my dear friend, please design a sliding contact bearing or choose a rolling contact bearing for particular application. Then as a design engineer, you should know what are all the parameters I need to choose in order to design a bearing, and what is the final requirement a bearing should fulfill, what purpose it has to serve. So here we need to get lot of clarity, and then we need to move ahead step by step. So today let me share few aspects. As I've told you, few aspects with regard to the shafts. Okay, shaft has to be strength enough, it should not break, and the shaft should not undergo more amount of deformation while transmitting the power. So it should be equally strong, and it should satisfy strength criteria, and it should satisfy the stiffness criteria. So these are the requirements for the shaft. Equally for every bearing what we are going to have, there are few specifications or the few requirements we need to satisfy. So today let me share with you few of the insights which will become the fundamental requirements with regard to the design of sliding contact bearings. Yeah. So having said these few words, let me say we all know that bearings are the machine elements that permit directed relative motion. This is very important term. So bearing is an element that will permit a directed relative motion between two paths, okay, while transmitting the forces from one part to the other part without allowing motion in the direction of the applied loads. That means if I am applying the load in this direction, I should never have the rotation of this particular bearing in opposite to this one. So this should strictly be avoided. Okay, so this is what is the basic function of a bearing. And when we talk of the bearings, we have most widely two types of bearings we use in engineering. Apart from these two types, we have many other types, but they are not of that important as far as manufacturing industry is concerned. So the bearing what we see here, see, this is the shaft, man. This is the shaft, okay, and length of the shaft could be very big, and there can be pulley on it, and there can be a gear, and there can be a spur gear, helical gear, bevel gear. So many components may mount on this particular shaft, but all those components will induce forces perpendicular to the shaft direction as well as along the shaft direction. So accordingly, a shaft may be subjected to a radial loads as well as to the axial load, and I need to support it. This support has brought in, or people have classified it in terms of two configurations. One is sliding contact bearings. This is what I have shown here is an example of sliding contact bearings, and right side is a rolling contact bearing, or even we can call this one as the anti-friction bearings, because the friction in rolling contact is very less, therefore even people call this one as the anti-friction bearings. Whereas in sliding contact bearings, we are going to have the shaft, surrounding the shaft we are going to have the bearing, and these two are going to slide against each other. That is the beautiful point. These two components are going to slide because shaft is there. It is sliding in. It is sliding inside the hole. So therefore, this bearing is known as the sliding contact bearing. But imagine, just as a design engineer, just think of there is a shaft and it is rotating at a tremendous speed, let us say at some omega, and I have supported it at these 2 points. I have supported it at these 2 points. Let us say these two are the bearing locations where I have supported, and the shaft is rotating at enormous speed. And just think for a while, if between these two nothing is kept, and this is material 1 for me and this is material 2, and if I allow these two materials to rub against each other, if I allow these two materials to rub against each other at these locations, you can imagine what pathetic condition it is going to produce. Enormous heat because of friction, enormous heat because of solid friction, or what we call it as a Coulomb's friction, is going to be generated, and more wear and tear. First of all, argipotai. Apart from that, if more wear increases, it will lead to tear, and these two phenomena in turn will lead to enormous heat generation. And over the period of time, if I run it, even the temperature may lead to such a stage where these components may melt off. So such is the seriousness we are going to face with regard to the bearings. So in that aspect, the prima facie requirement for an engineer is, whenever I talk of a bearing, my intention is I want to reduce the friction. So first intention is of any bearing is, whatever the bearing I design, it should drastically bring down the friction. You know what is a friction, drive friction and coefficient of friction and static friction. So much you have learned. So primary importance is a reduction of the friction. So accordingly, we can use the sliding contact bearings and we can use the rolling contact bearings. Okay, right. So having said that, we have sliding contact bearings and we have rolling contact bearings. So plain bearings are generally applied wherein we have reciprocating sliders like IC engines, and most of the annular sleeves and most of the rotating disc and machinery. And the advantages of plain bearings are nothing but, as I told you, plain bearings are nothing but sliding contact bearing. The other name for sliding contact bearings is a plain bearings, where you have the rubbing action between the two surfaces that are having relative motion with regard to each other. So the advantages with the sliding contact bearings is, generally when we design, they are low cost, because you are going to have a metal surface. Inside the metal surface, the shaft is going to sit. So not much cost is involved with regard to the design. So therefore the cost of these bearings is less. Secondly, the design is very simple, because all our circular members designing is very easy, because you don't have complex shapes wherein you need to apply a lot of mathematics and engineering to come up with the structures. And thirdly, you are going to have a small radial space. Generally shafts are of a small diameter, whatever the shaft diameter is there, that much space only we are going to occupy. And most of the sliding bearings are quite in operation because you don't have too many components. What you have a shaft, and surrounding the shaft you are going to have a bearing, and between these two, we know down the line we will see, between these two we are going to provide the third component, what we call it as a lubricant. Okay, what we call it as a lubricant. So green one is the bearing, and red one is the shaft, and whatever the liquid we keep to separate these two is what we call it as a lubricant, which we will stress a lot down the line. And these are not very sensitive to dust. Even a lot of dust will gather also. The performance of these bearings will not get affected, and these are less subjected to the fatigue failure. As you know, fatigue loads are the loads wherein either the magnitude or the direction do change as a function of time. So accordingly, you have a variety of models, and you know how to model the fatigue as a part of second unit in design of machine members. And failure is very small, and the danger we encounter with them is going to be less, and they are lightweight. Now see, this is a very good example. IC engine, it is the engine we find in cars. If you open the bonnet and you try to see that one, you are going to see an engine. If somebody opens, you will see. And if you see this engine, it is a 4-cylinder, because see, this is cylinder 1, cylinder 2, cylinder 3, and cylinder 4. 1, 2, 3, and 4 cylinders. As you know very well, my friends, piston is connected to the gudgeon pin, and there is a relative motion between the piston and gudgeon pin. And if I do not provide sufficient lubrication or reduce the friction over the period of time, whatever the gudgeon pin hole I have made, it will elongate, and it will become bigger, and thereby the whole engine will collapse down the line. And this is a connecting rod, because already you have studied IC engines. We have a connecting rod here, this one. So connecting rod is connected to the crankshaft here, and the crankshaft is supported on the bearings because it's going to rotate, and this is the flywheel. And this is the flywheel, you know very well why flywheel use. So this whole structure is going to rotate. Imagine the speed with which these pistons are oscillating, and enormous speed with which this crankshaft bearing is rotating, and how much it could be generated if I do not use a proper lubricant between them. You just see, for example, sometime you try to rub your two hands, after some time you feel like not rubbing, because such an enormous heat would be generated because of friction. Imagine once two metals come in contact and try to rub against each other, how much heat is going to be generated. And if I do not address, this may be a very pathetic situation. So like this, these are all the places where people mostly use sliding contact bearings. So this is how basically a whole configuration of a sliding contact bearing will look like. And for seeing this, it is very easy. Everybody may say, what are there? There is one shaft here, and this is the bearing surface. And between these two, this whatever the yellow part that I have shown, this is going to be the lubricant. This is going to be the lubricant. And people may think, what is there? I can use a shaft and I can have the housing and I can introduce some lubricant. No, no, no. Because in the process of rotation of the shaft, you should equally make sure of yourselves whether there is a metal to metal contact existing in the due course of rotation between the shaft and the bearing surface or not. So this is a bigger challenge with regard to the design of sliding contact bearings. So now I will define the purpose. What is the function of the sliding contact bearings and what are the design aspects? So in the due course of rotation, I don't want there to occur a metal to metal contact, first thing. So because there is a shaft, it is made of one material, and there is a housing, it can be made of some other material, and I don't want to have metal to metal contact. This is the first constraint I will keep. The next question comes, how do I make sure in due course of rotation of these two components, there is no metal to metal contact? If metal to metal contact happens, I'm very sure the show is closed. Bearing is down the line going to fail at the flop. Second important, in order to achieve this particular purpose, metal to metal, I need to choose which lubricant should I use. Which lubricant should I select or should I use? This is the second aspect a design engineer need to keep in mind for this particular bearing. Third point of is, what is at which speed I should allow my shaft to run? At which speed the shaft should run? Because if you design the shaft to be running at 900 RPM and tomorrow somebody comes and try to operate the shaft at some 2000 RPM, whole physics or all the parameters what you have decided for that bearing will fail, and it will lead to a catastrophic failure. Okay, and what lubricant you should use, and finally what should be the cost, and in due process how much heat this whole bearing is generating because of the rotation, how much heat it is generated, and am I able to successfully dissipate this heat to the atmosphere so that the bearing always operates in equilibrium condition. See, equilibrium is such a big term in engineering. We are all in equilibrium, therefore we are existing. If there is no equilibrium, and if something goes on increasing as a function of time or decreasing as a function of time, always those systems are going to collapse. So these are the basic objectives for the design engineer when he talks of the sliding contact bearing. Now let us see how people have gone through that one. So in order to have this sliding contact, first of all, we cannot avoid talking of a lubrication. So therefore lubricants have come. You know how costly the lubricants oil are. Whenever you go take your motorcycle for a repair and you want to change the engine oil is more costly. So such is the value of the lubrication. You know that lubrication is the science of reducing friction by the application of suitable substance called lubricants. So in order to design the journal bearing, I should have primarily the idea of all the lubricants that are available in the market. Who are all the people making or producing lubricants, and what are their characteristics? And accordingly, lubricants can be liquid lubricants such as mineral or vegetable oils, most of the motorcycles we use, and they can be semi-solid such as a grease, because grease has a very good property of bringing down the friction. And sometimes a few metals itself like graphite and molybdenum, because of their molecular structure and their the very constitution of the material, they do act as a bearing material, and those things we call them as a solid lubricants. So the objectives are very simple, always we want to reduce the friction, and we want to prevent the wear, and we want to carry away the amount of heat that is generated because of friction. These are the primary requirements of a particular lubricant and we need to protect the journal and the bearing from corrosion. Okay, I don't want the things to get corroded. Having said that, these are the different types of lubricants you have. Let me not go deep into them, but let us come back to the very important part of the design of a sliding contact bearing. So when I talk of a sliding contact bearing, we have to talk of how many types of lubrication I can provide to a sliding contact bearing. Very important. So accordingly, types of lubrications, if you see, you have a full film lubrication, we have mixed film lubrication, and we have boundary lubrication. If somebody is into design of a sliding contact bearing without understanding these fundamentals, I'm not very sure that nobody can get into the design. So what is a full film lubrication? In a full film lubrication, I have a shaft, always I have a shaft, and surrounding this one, I am going to have what you can call it as a bearing, and between the bearing and the shaft, I am going to place a lubricant. And if the shaft and the bearing, if they are always separated by a thick film of lubricant, if always I see that there is a thick film of lubricant between the two rubbing surfaces, that is what we call it as a full film lubrication. And sometimes I may even provide not fully separated, but sometimes there can come metal to metal contact, but sometimes there can be a thin film of lubricant between the two rubbing surfaces. So that condition is what we call it as a mixed film lubrication. And the last one is the boundary lubrication. Okay, boundary lubrication, where mostly the surfaces will rub against each other. So this boundary lubrication mostly will come in the gears. When two gears are in motion, and sometimes only a thin film of lubricant will come between two surfaces, but most of the times it is the surfaces that rub against each other. And most of the times people do not worry about these two. These two are pretty easy, and they cannot be done. But the big challenge people face is, how can I develop a full film lubrication? So this full film lubrication can be achieved by hydrostatic mechanism, hydrodynamic mechanism, and elasto-hydrodynamic mechanism. So that means in hydrostatic lubrication, what we do, it refers to the state of lubrication wherein a continuous supply of a lubricant, okay, lubricant generally we can call it as oil, is definitely placed between the two separated surfaces. So this is the shaft I call, as of now I am calling shaft, and as of now I am calling this one as the bearing surface. So between these two parts, by making use of a pump and a sump of oil, with pressure I can pump in the lubricant so that